This is the base. The base is the number that's being repeatedly multiplied, right? A power is repeated multiplication. So I'm going to be multiplying 5, and we look to the exponent to tell us how many times to multiply it. So I'm going to multiply the base 3 times. What's 5 times 5 times 5? 125, good. Okay, and if you want to use your calculator to punch this in, you would punch in 5. You have to look at your calculator. Some calculators have this button, or some of them have a button that looks like this, or that looks like this. Okay, so the exponent laws that we're going to review are when we are multiplying powers or dividing powers or power of a power, but it all deals with powers with the same base. So I want you to write that down. They have to have the same base. If not, these laws don't work, okay? First rule is if you're multiplying powers with the same base, so as an example, let's do 2 to the power of 3 times 2 to the power of 2. Well, what does 2 to the power of 3 mean? 2 times 2 times 2, okay? And what does 2 to the power of 2 mean? Times 2 times 2. Okay, so I'm multiplying 2 to the power of 3. So I'm multiplying the number 2 3 times, and then I'm multiplying that by another 2 times 2, right? If I were to ask you to express this as a single power, well, what's the base? 2. And how many times did I write the base altogether? So the answer is 2 to the power of 5. Do you guys remember this from grade 9? What's a shortcut? Look at your exponents. Add the exponents, okay? So when you're multiplying powers with the same base, step 1, write the base. And then as a shortcut, all you have to do is add the exponents, okay? Because we're multiplying. So we're repeating it 3 times, and then you're repeating it another 2 times. 3 plus 2 is altogether repeated it 5 times, okay? Just using symbols. If the base was x, write the base. What's the base? And add the exponents, so it would be n plus m, whatever those numbers are, okay? Just using symbols. This is just to show you that all you're doing is adding the exponents. N plus m would be your answer. Second exponent law is if you're dividing powers with the same base. So someone give me an example of 2 powers with the same base. Let's do 6 divided by 2 to the power of 4, okay? 2 to the power of 6, I'm writing the base how many times? 1, 2, 3, 4, 5, 6, divided by 4, writing the base 4 times. What happens when you divide a number by itself? Cancels out, right? Becomes 1. What am I left with? As a single power, how many 2's am I left with? So the answer would be 2 to the power of 2. What's the shortcut? What do you notice? Look at the exponents. What's a quick way to do this? Subtract the exponents, okay? So when you're dividing powers with the same base, write the base. Okay, you always write the base first. And then for division, we would subtract the exponents. For multiplication, you would add the exponents, okay? Okay, so just using symbols again. Write the base. What's the base? Of x to the power of n divided by x to the power of n. M, what's the base? X. And what do I do with the exponents? So n take away m. This is just in symbols, okay? The last exponent law is if you have a power of a power. So this is an example of a power of a power. I have 2 to the power of 3, right? That's my power. All of that to the power of 2. So if we look at this separate, this is the base of this power, right? I have 2 to the power of 3. How many times should I write 2 to the power of 3? Twice. So I'm going to write 2 to the power of 3 times 2 to the power of 3. Right? We're writing the base twice. This whole thing is the base. Now we have a multiplication question. I have 2 to the power of 3 times 2 to the power of 3. What do you do when you're multiplying powers? What do I do with the exponents? So it becomes 2 to the power of 6. Shortcut. Look at the exponents and look at my answer. What's the shortcut? What can you actually do? Multiply. Good. Okay, so last rule, write the base. And then multiply the exponents. And if we write this in symbols, x to the power of n to the power of m becomes what? What's the base? X to the power of n times m. Just using symbols, okay? Just write these as a single power. So 6 to the power of 2 times 6 to the power of 3 would be 6 to the power of, good, b. 7 to the power of, subtract the exponents, c. Good. Now, when we get to d, it's everything inside this bracket to the power of 2. So it's actually 1 to the power of 2, and it's 2 to the power of 3 to the power of 2. What does 2 to the power of 3 to the power of 2 become? 2 to the power of 6, right? Because we're multiplying the exponents. So you can write it as 1 to the power of 2 divided by 2 to the power of 6. If we were to evaluate this, let's keep it as a fraction. What's 1 to the power of 2? What's 1 times 1? What's 2 to the power of 6? You'll need a calculator. What's 2 times 2 times 2 times 2 times 2 times 2? So 1 over 64. If we were to evaluate this, if you want to turn it into a decimal, how would you turn this into a decimal? 1 divided by 64. What is it? 0.0156. Okay, and so on. We'll just round it. Okay, so let's work with the numerator first. The numerator is 4 to the power of 5. All of this to the power of 2. What does that become? 4 to the power of 10. Good. Divided by, what's my denominator? 4 to the power of 2. All of this to the power of 2 as well. What does that become? 4 to the power of 4. Can we simplify this more? Yeah, because this is division, right? 4 to the power of 10 divided by 4 to the power of 4. What do I do with the exponents if we're dividing powers? Subtract, so it becomes 4 to the power of, good.
Made with Doodlecast Pro.